So what about moisture content in slabs, basement slabs, and moisture moving up through the basement slab? Because we do know that if there's no moisture barrier between the soil below the slab and the slab, the soil's porous, the concrete's porous, you can have many, many pounds or pints of water moving up through a slab and you'll never see it because it moves as a liquid through the pores, but when it gets near the surface or at the surface of the concrete, it evaporates. And so it's not leaving behind any efflorescence. All you'll see is a higher moisture content in the air mass above that concrete slab or concrete wall. But we have to have some way of assessing all of this. So remember before I told you that there was a line here, this white mastic line, where on this side of the concrete there is no moisture barrier beneath the slab because it's 100 years old. But here, this portion I had to pour because it was bare dirt, I do know there's a moisture barrier, a heavy 10 mil plastic underneath this slab. So there is a capillary break between the soil below and the concrete above. So this is where we go to the moisture meter, and we're going to go and move the scale to 2, and 2 is called the relative scale. And on the BD2100, it's a scale from 0 to 100, and it's not based on the laboratory testing of wood sample after wood sample or drywall sample after drywall sample to establish a numerical relationship, a fixed relationship, and get the percent moisture content by weight. This is a relative scale. So what does that mean? It means that, and why do we use a relative scale for concrete? Why can't we use an absolute scale like we do for wood and drywall? Well, the reason is because the makeup of concrete varies widely in terms of the proportions of different materials, the type of materials that are used for aggregate, the different types of Portland cement mixes. There's too much variability to have a single relationship between the moisture content and the conductivity between the pins. So all we can do is get a relative measurement. So, many years ago, what we do is take a square of plastic and tape it down about a meter or a yard square and wait for 72 hours and see if we could find trapped moisture on the underside of that plastic. And that would be evidence of moisture moving, being transmitted as a liquid close to or near the surface and then evaporating off. Instead of evaporating in the air, it will condense on the underside of the plastic. The problem is that gives way too many false negatives. So the new, and this is in the blog that you're reading about extending the reach of moisture meters, the standard requires that you measure down 40% of the thickness of the mass that you're measuring for concrete. So if this is a 4-inch slab, 40% down is 1.5 inches into the slab. So what you can see here is I've got 2 holes that I've drilled with a masonry bit, and then it's pretty slick, but these concrete nails have that little plastic sleeve that keeps the metal from touching the side. And so I insert it down into the hole, going down to the appropriate depth, and because I've drilled the holes the right depth, and the sleeve keeps that from touching the side. And then I can take my moisture meter and I can put it on scale 2, which I've got, and then I can touch it to the pins, and I will get a relative reading. Now I've got this hole has been, drying out. So that's saying, that is saying 43. And that's an absolute scale out of 100. Now, what I can do is take the moisture content here and use it as a baseline. What I mean is that I know there's a moisture barrier beneath this. So the reading that I get on a relative scale from 0 to 100, this is my baseline. So I'm going to take the same, and by the way, after you drill the holes, there'll be dust in the bottom, and you don't want to measure the dust. So I very carefully, when I'm doing this, clean out the dust from the bottom of the hole. And I wait just a little while because the heating up of the drill bit can also, that heat can drive moisture off. So you have to get the dust out of the hole, and you have to wait to let the temperature, you don't have to wait long, wait a couple minutes for the temperature to drop so that you're getting a better reading of the true moisture content down 1.5 inches deep. So all I'm going to show you is that in this basement, I'm going to move to the other side of the basement and show you that, over here what I did was I drilled 2 more holes. And then I go through the same moisture test, and I want to compare the moisture reading that I get here, 0 to 100, compared to my baseline. And so when you do a relative measurement of concrete for moisture content, you got to drill down 40% through the thickness, because it'll be much drier for that first 1.5 inches, and you'll get a much more accurate reading if you go down that 40% into the slab. And of course, again, you have to do a relative reading because different concrete mixes vary widely, and you can't use a single relationship like you can for wood or for gypsum wallboard. So we can do measurements of materials like wood, like drywall, and concrete, with wooden drywall having scales where we can get percent moisture content by weight, a real measurement. And then for concrete, because of the variability of the composition, we can only get a relative measurement.